So today we discuss refraction of lens part B. Okay. So the part B is the formation of image by a lens. We discuss formation of image by a lens. A new topic. Okay. Previous class we discussed the type of lenses, convex and concave lenses. Here we draw the images with the help of lenses. Okay, so you know that is two types of lens. This is the convex lens. Okay, and that is the focus. Okay, here that is f1 first focus of, if that is called, if that distance optical center at that distance is focal length, and same focal length distance here, focal length the left side. Okay, so get FL, so get a focus here. Okay, actually this length and this length is equal, that is focal length, that is called a convex lens. uh, Now we draw a concave lens. Now this lens is look like this. Principal axis, optical center. There is a two type of focus, f1 the principal focus, and here is also f1, and that is a focal length, that distance from optical center to focus. So we get a focal length, and that is also a focal length. Okay, so here that the principle of ray for constructing a ray diagram. Okay, there is some law or rules, okay, for drawing an image. For the rule or law for drawing image or formation of image. Okay, so rule number one, that is a convex lens. The principal axis, the principal axis, consider that is the principal axis. Okay, really draw a, tough to draw a straight line actually. Okay, and that is a focus f1. If I say that is also called a f1. Okay, but both focal length are the same. That's the principal axis. If that incident ray parallel to principal axis is, okay, if incident ray parallel to principal axis, then after refraction these refracted ray passes through that f1. Okay, this focus, the rule number one. And if I draw similar that concave mirror or concave lens also, that's the principal axis, and that is a f1. Similar, that is also f1. If incident ray parallel to principal axis, so after striking, the reflected ray, that is the reflected ray, passes through the focus. Actually, there is a divergence. Okay, that's why is a focus. Okay, very important. That is incident after striking, they passes through the after striking, the striking, the refracted ray for convex lens, for convex lens, the refracted ray passes through focus. same as a concave lens, but that is a reflected ray, passes through the focus. Okay, that's a reflected ray. Next rule, rule number 2. And the rule number 2, similar, first we draw a lens, that is a convex lens. Okay, that's the principal axis, optical center. Okay, that is F1 first focus, that is a 2 of first focus, or also called a principal focus. If a incident ray actually passes through the optical center, actually incident ray optical center, so they do not deviate actually, so do not deviate, that ray similarly passes through this line, so don't deviate it, follow straight line. Okay, if incident ray fall on an optical center, if incident ray falls on optical center, that is a convex lens, as a principal axis, that is a F1, optical center, that is also F1. Similar, that is same condition, if incident ray fall on optical center, then passes through that line. Do not deviate. Okay, actually they passes the straight line. Okay, not deviated. Same condition here for concave lens. Do not deviate. Same, follow the convex lens also. They do not deviate. They passes through the and follow the straight line actually. Next, rule number 3. Rule number 3. Convex lens, optical center, first focus as the first focus. Okay. If incident ray passes through the first focus line actually, look like this. That the incident ray. Okay. Then after refracted, they parallel to the principal axis. To principal axis. Principal axis. Similar case as concave lens. Okay. That is the F1. That is also F1. If incident ray falls on passes through the F1, they follow the straight path actually. Okay. The straight path. And these are striking that equation. Okay, so we get that is third number case. Case number 3 is incident ray passes through F1, then refracted ray parallel to principal axis. Similar case, both are that a convex lens, that is concave lens. Both have same. If all these, then the refracted and reflected both are parallel to the principal axis. Then law number 4. Okay, that is a three steps or three rules for drawing a image. Actually, these three rules are very important actually. Okay, see that very carefully and always follow that rules of this. Next condition. So there are the two kind of images, and real image and virtual image. Previous class we discussed, and this type of left side of what is the create of that principal real focus and virtual focus. That's a similarly case of the real image and virtual image. The real image, real and virtual image. Okay. So what is real image and what is virtual image? If the ray from a point of object after diffraction through a lens actually meet a point. So if I write a definition of real image, the ray from a point, the ray from a point and of an object after refraction, after refraction through a lens actually meet a point. Actually meet a point. So that's the image is called a real image. Okay, that image is called a real image. So look like this. If I draw a convex lens and there is an incident ray, here is an object. That is an object, that is a head position. Okay, and that is the incident ray parallel to the principal axis. Okay, so that is a, say that is f1, and this ray after striking it passes through the f, the a. Okay, the a. So that is the head of the object. Okay, head of the object passes through the f1, and need another point. If ray that another ray passes through the optical center, so we see that that is a midpoint. Okay, so actually that is a head. Okay, that is a head. And if another important point, okay, so point say that if a ray, incident ray passes through the optical center, so they do not deviate, they follow the straight path, obviously parallel to principal axis. Similar case here, if that is a leg bottom position, a top A bottom B passes through the optical center, so they do not deviate, they follow the straight path. So you see that head of the object goes down, okay, and leg is upward. So you see that this image, okay, this image is a real image. This image is a real image because this image creates in screen, and see that that is a meet a two point from a point object after reference to a lens meet a point. Okay, you see the meet a point. Okay, the important line meet a point. Okay, meet a point. You see that very carefully. That the meet point. That the meet point after refraction. So that's why this image is called real image. Okay, the ray from a point of an object, after refraction through a lens actually meet a point. So actual point is here. That is the head to hand, and that is leg. So that is the B, and here is the A. It's actually inverted. Okay, that's image a real image. And what is the virtual image? So virtual image. Okay. So definition: a ray from a point. Definition: the ray from a point of an object of an object after refraction through a lens through um, a lens do not actually meet a point. So, meet a point. Okay, so meet a point, but but they appear uh, appear to diverge from a point. To a point. Okay, and this image is virtual. So, this image virtual is virtual. Okay, now I draw a diagram actually. So that is choose a concave lens, a principal axis, optical center. See that the object here, there's the object A, and that is B. The head of the object actually top passes to the principal axis. Okay, and see there's a diverge. So if I back to actually this line and this line is parallel. Okay, it is the same line passes through the focus and choose another line. This line do not deviate actually. If I say do not deviate means they actually same. These are the same. So if we choose a dotted off, um, these two are the same. Okay, and you see that is sorry. Another important point is the bottom of B. That is a follow state path. Okay, and similar back here. But you see the very carefully the top A actually they diverge here. Okay, and from these they diverge here, but they do not actually. This if I draw a straight line, if I follow imaginary line, draw imaginary line, that imaginary line passes through the focus for concave lens. Okay, and if I one ray of ray passes through the optical center, so do not diverge the state like this. These are all state. So here is a something problem, that is a do not meet point, and you see, if you see the very carefully, they actually meet. They actually meet here, but this is the imaginary line, not a actual line. Okay, so head and there is a leg. Okay, so that is A and B. No, not inverted. Okay, and that type of image is called virtual image. This image is virtual image. Why this is a virtual image? Because you see that from definition, they do not actually meet a point. Okay, underline the important. They do not actually meet a point, but they appear to diverge from a point. Okay, so but they do not actually meet a point, but they appear to diverge from a point. Okay, that's important. From these to diverge from a point. Okay, so that's why this image is called virtual image. That is not a original line actually. So that is the imaginary line. That ray actually passes from there. So that do not meet actually. So that is these images a virtual image. So maximum concave lens create a virtual image. Actually screen here. Screen is here, but you see that very carefully. Real image create on a screen, but virtual image do not create on a screen. They create the same side of the object. Okay. So if I difference between these two, very important. Difference between real image and virtual image, we distinguish between two. Distinguish between real image and virtual image. See very carefully. Okay, real image actually intersection from a ray. Okay, real image actually intersection from a ray after refraction. Actually meet a point after rays, actually refracted ray actually meet a point after refraction. Okay, actually meet a point. That's the key point. Actually meet a point. But the virtual image is they appear to meet a point. Okay, they appear to meet a point, but they do not meet. Okay. Next, number 2. Real image can be obtained on screen. Okay. Image obtained on the screen and not obtained on the screen. Number 3. Okay. Real image inverted with respect to object. Real image inverted with the object. And number 3, say erect, okay, but with respect to object. They are erect with respect to object. Erect with respect to object. Okay, that is simple. That is another example is concave lens, and that is a convex lens. Okay, let's see that. Okay, so for concave lens, and that is a convex lens. Clear? That's the importance of real image and virtual image, and basic 3 rules and laws. To say anything, the rule, law, and say the rule. Okay, and that is for drawing a image. Okay, very important for drawing a image. Okay, so next class we discuss the construction of a ray diagram for a lens. Construction. Okay, the basic idea. Next class we draw a construction. So today in the class here. Okay, thank you.